Yo, hello. I'm talking to you again through my computer, which is different than me talking to you through a microphone, just so you know. So if I say I'm talking to you through my computer, you might say, what's the difference? Aren't you always talking to us through your computer, Dutch? But this time I'm literally talking to my tower. There's like a microphone array built into the tower, and my other microphone is not here in the office yet. Long story on that. Probably going to have to get a new mic, actually. That's what sucks. Those things are expensive, especially for one that like actually gets your voice okay. Anyway, we're not here to talk about my voice, but you can hear my voice. I want to show you something that's just happened, and it's happened over the past few hours. So, since doing my last update, there were two new earthquakes that popped off here that are fairly significant. Listen up, everybody. Guys, I'm not joking, okay? Like, seriously. Look, I get in trouble from time to time for talking about certain things, but there's certain things I've got to show you because of shit like this. So we got the 3.8 that we talked about in my update all the way up here next to Sulphur Peak and the volcanoes, China Hat Butte, up there at the Wyoming-Idaho border region. Then after that, of course, we talked about watching for the same sized earthquakes to go across the plate. And then within a magnitude, a 3.1 struck down here at Oklahoma, then a 3.1 struck down here off the coast, very rare, off the coast of Louisiana, Mississippi, and Alabama in the South United States, down there in the Gulf of America, formerly known as the Gulf of Mexico. But let's go look up this 3.1 in Oklahoma first at Pawnee, Oklahoma, and go take a look and see what is at the location. So let's put the coordinates in. This is for the 3.1 in Oklahoma first. So I did my update talking about looking for the same sized earthquakes relatively, well, I mean, within the magnitude to go across the plate. And then this happens right here. This is Pawnee, Oklahoma. And I don't know where our nearest drill points are, but I'm going to have to guess they're probably pretty close by. Let's just look around and see if we can find any nearby drill points. I always look within a few miles. So if I find one in the same block, the farmer's block, like this right here, this is a drill point for fracking for oil and gas. That's one. Is this another one here? This is another one here. That's two. Here's a third one. Three. Across the street, out the field here. Four. Five. Six. Plus a, well, 7, 8, 9. Wow, there's like three at that spot. Okay. Well, I'll just say it. We've got plenty of drill points around the location. That's definitely close enough. All of this is drilled right here. Bing, 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 bing. And the greater area most likely has more, but we only need to find the nearest wells since those are the likely culprits. Now, the drill points are just leading to the wave being caught at this location. Same like up to the northwest, that's at the volcanic location. It's catching the seismic wave at the break points in the plate that Mother Nature created. In this case, it's on the edge of the craton down in Oklahoma, where man has drilled in. Same with all these earthquakes in Texas. I shouldn't need to show you, but this is the rare one that makes me laugh. Gulf Shores, Alabama is where it's off the shores of Gulf Shores. Have you ever been down to Gulf Shores? Went with the wife's family on a week-long excursion down to Gulf Shores where wife's family rented a beach house that's on stilts because it's like right on the beach. And man, we partied hard down in Gulf Shores. But Gulf Shores is a fair distance away. You see, let's get a line measurement and just see how far Gulf Shores really is. 71 miles away, or 70. Here, hold on. 70.7, 71 miles away to the north is Gulf Shores. So we're 70 miles off the coast out here. Now, if you go to Gulf Shores and you look 18 to 20 miles off the coast, you can see in many cases what are offshore rigs And that extends down here. They don't have them imaged here at all. You can't see them here on this Google imagery. They're showing you the ocean floor, not really showing us any offshore rigs off the coast of Gulf shores, but rigs by like oil, I mean. But then you go further out here and you get out to these locations. These are what are known as salt domes. They're giant domes of salt. They go down into the plate. Think of your teeth and how they go down into your gums and spread out into spikes almost, right? Well, the same thing is for these. And these are just a small portion of them. There's so many of them. Look at how many salt domes there are. See, these are all salt domes from the ancient craton. This is proof that the plate hasn't moved much over the entire history of the Earth. This is proof that plate tectonics is BS and the plates have not shifted a long time over a large distance, because these are all millions or hundreds of millions of years old, and they're all in the same spot, attached to the same plate, and it hasn't moved much or left a trail of them. Therefore, this has always been here, and it hasn't moved. Therefore, the plates haven't moved. Therefore, Pangea is bullshit. But that being said, we get back over here to the edge of the ancient salt domes, and the salt domes go onto land. There's some up here in Louisiana. Let me show you. Bayoucornela. Bayou Corn, Louisiana. And several years ago, out here at Bayou Corn, right here, the Bayou Corn sinkhole formed. Now this is a oil petroleum storage location. What does a salt dome have to do with a oil storage location? And why did this one collapse? Well, these salt domes go underneath the plate. They start out here in the ocean. And someone a long time ago in the 1940s or 50s figured out that you could drill into these salt domes and remove the salt by pumping in water deep down into the middle of the dome, many miles wide. And you could create a cavity inside the dome, like a cavity in your tooth, hence my tooth analogy just a few minutes ago. And by pumping water down into the salt dome, they then remove the water out and they get brine solution, a brine water. And they use that brine water in the oil industry. They'll pump it off and they'll inject a salt dome and create a cavity inside of it. Giant, huge, many more than Olympic swimming pools. I'm talking like acres worth of area cleared out. And then what they do is they'll pump oil down into the empty cavity inside the salt dome. And they will then cap it off on the top and store it as part of what's called the Strategic Petroleum Oil Reserves. And you've maybe heard of that, where the president talks about it from time to time, the strategic reserves. Well, part of the strategic reserves are stored in salt domes. They don't tell us exactly where, but you can find out where they start doing it on land, I mean. But out here in the ocean, they found that there's oil next to salt domes. And they can drill into this out here, the sedimentary layers out here next to the salt domes, and extract oil and then also pump it into the salt domes out here to store it. You may have heard of something called the Deepwater Horizon. Deepwater Horizon. Oh, are you kidding me? It's not going to come up? Hold. Deepwater Horizon platform location. Do we have coordinates for this dang thing? Are we gonna just get, like, come on, man, like, where are Bing, copy, paste. I need to have this in a place mark anyways, so I'm just gonna place mark this once we get there. Oh, hold on. There we go. Well, I'll be darned. Oh, wow, what do you know? It's right next to the earthquake location. Hold on. Hold. We're going to pull up. Hold. Hold. Braveheart. Deepwater Horizon. Please tell me you can see all this. You don't see any of it. Holy shit. You don't see any of this? All right, we're starting over. Class, we're starting over. I told you I don't read chat. I should. I've only got one screen in front of me right now, though. So how do I do? I'd have to have like my phone open or something and sit there and read the chat room while I'm trying to talk. I'm such an idiot. I promise you, I pressed screen capture on. But apparently I didn't press it hard enough, or I clicked in the wrong spot. Okay, well, you know, when this happens, you can tell I haven't done any live broadcasting for a while because I just made a major error that I would have made, maybe a noob error that's only happened a few times in my entire existence being online. There's a streaming thing that you need to know if you guys want to ever stream. You should often have your stream open on another screen somewhere off to the side so you can see if there's any problems. And it's unwise to try to stream with one screen and nothing else showing you what's going on. You imagine me with a bank of screens around me or something? I've got one freaking screen in front of me right now. I'm sitting at a desk with one screen, like I'm in an office or something. Well, I am in an office, but... Well, for crying out loud, let's start over, class. So we have a line of earthquakes that's going across the edge of the North American craton. You know what? I probably should start over because that's really where I needed to begin this. So you really didn't miss much. Let's do this over. This, look up in the northwest, up at Idaho, pointing into Wyoming, and then look down at Texas, and then look at Oklahoma with the hook right there, and then look down off the coast of Louisiana and Alabama, where it says coastal plain. So we have earthquakes coming in from the northwest. 3.8 up here next to Idaho and Wyoming. Then down here in Texas, a whole boatload of small earthquakes at the oil and drilling points in Texas. Now we're going to go look up Oklahoma again, and then we're going to go look up this location out here off the coast. But I've already spoiled it because it's next to the Deepwater Horizon well. The Deepwater Horizon BP oil spill well is right next to where this new earthquake struck, which I'll show you in a second. But first, let's drive home the point here that this is related to a wave going through the plate. And first it sought out the volcanic points up to the northwest. Then it sought out the drill points here in Oklahoma. And here in Oklahoma, here's the earthquake epicenter. And all around it are these oil and gas drill points, mainly gas for methane, fracking, wastewater injection. They'll inject water laden with chemicals, and then it breaks down the shale, releases oil and gas, and they recollect it. So all around the earthquake epicenter are these pads containing drill points that go down into the plate several thousand feet. So our earthquake here is next to the drill points, and the reason the earthquake struck there is there's a wave down in the plate that sought out these drill points, just like it sought out the volcano up to the northwest. And the wave is trying to go across the plate. Now, off the coast, we get the same sized earthquake. And this is the rare location, 114 kilometers south of Gulf Shores, or 70 miles. And we'll put the coordinates in. Paste and search. We're going off the coast, making sure you can see this. And Google shows us jack squat, right? Here's the earthquake epicenter. And let's mark that with just an untitled place mark right now, just so we can remember where the earthquake is. Because now we're going over to this here. Deepwater Horizon BP oil spill. This thing blew up. Now, there's a slight conspiracy surrounding this location about why it blew up. And I found this myself. I didn't see this anywhere else. I was looking up the location on Deepwater Horizon, and I found out that the U.S. Navy had an ordnance disposal site somewhere here, next to where the Deepwater Horizon site is. So somewhere to the east, right in here. The coordinates were listed pretty much right where the Deepwater Horizon well is. And the ordnance disposal site was for disposing underwater ordnance disposing ordnances underwater that were toxic that you wouldn't want blowing around in the air. So biological, chemical, that kind of stuff. That if they were going to destroy it, they're going to destroy it somewhere deep down in the ocean. And that was one of the sites here. So when Deepwater Horizon exploded, and there was no real explanation for why, but then they showed coming out of the ground out here a bunch of oil. Now, it may very well be that this is one of the strategic oil petroleum reserve locations and an ordnance disposal site where they would put an ordnance down in the salt dome. Not to cause a problem, but to dispose of it. And that may be what they were doing at Deepwater Horizon. That's just, again, that's the conspiracy. But the fact that the two locations even nearly match is just too much, right? For the huge explosion to happen there. Well, regardless of why it exploded, right next to it is where our new 3.1 earthquake is, right next to these salt domes. Now, these salt domes are here, they're on the screen. That's just a few of them. Look how many there really are. All of these are salt domes. And then they see how this blurs out? That's not accurate, by the way. So they're not really showing them to you coming in on, because there's a whole bunch of offshore rigs that are out here that I'll show you. Maybe they'll show them, maybe they won't. No. That they don't even show us that are on domes like these that you would see at the surface. So, and I think that's for national security purposes is probably why they don't show them. This is not accurate in the way it looks right here along the coast. It looks more like this. Anyway, out here deep sea, these are our domes that you can see out in the ocean. And then coming onto land, we get to Bayou Corn, Louisiana. And this is something that happened about 10 years ago. 10 years ago, the salt dome below this location, which is forested and in the swamp now, collapsed. But what they were doing was they were originally pumping oil to be stored in the dome. And the way they do that, I already described it once, but I'll show it to you again out here off the coast. Suppose you go to one of these salt domes here, and you drill into it from a well like Deepwater Horizon, from a drill point like a platform like Deepwater Horizon, and then you hollow out the inside of the dome by pumping water down in and bringing it back out. And that creates a cavity down inside of it like a tooth. And these go down into the plate like teeth, like into your gums. So when you see this, imagine this is a molar tooth and that this would go down into the plate and spread out into roots that go down into the plate. Now, these are all salt domes, and I don't know how many times they penetrated the salt domes and filled them. I know that the National Strategic Petroleum Oil Reserve places some of the oil that they reserve out in the domes. Whether they're on land or out in the sea, I do not know. I know they do it on land. That's what collapsed at Bayou Corn. And these are all oil, by the way. All this stuff's oil. So oil storage and also extraction is taking place at these locations. That being said, this spot over here, the edge of the domes going over to the east, it has to be related to the domes, to the salt domes themselves, and the edge of the craton to the southeast, the drill points that would theoretically be somewhere through here. And we know they are because Deepwater Horizon penetrated something and let a whole bunch out. And anywhere around this, what if this whole basin, for instance, let me just propose this to you, that they're drilling in here, Strategic Petroleum Reserve is also in one of these domes, and then there's a bunch of oil down below it, just by chance. And they're drilling in for one thing, and another thing happens. Ordnance disposal happens. All of a sudden, it releases a boatload of oil, which covered almost the whole Gulf, or at least a good portion of it. That was the BP oil spill that came rocketing up out of the ocean floor, all the oil. Well, this will eventually depress over time as more and more seeps out. That would be one cause, drill points. Another, edge of the craton itself, pushing all the way down to the coast, but that's much too odd to be next to where we're going to be drilling. I mean, why not be out in the middle of the Gulf of America? Right? Oh, wow. So anyway, I mean, of all the locations to be next to, it's the spot that here, again, Deepwater Horizon right there. Let's get a measurement and see how far we are. 48 miles. For my international audience, that is 77 kilometers. Hop, skip, and a jump away. Same location, same region. I'll just say it. I mean, are there any other offshore rigs that we need to know about out here? I guess is the. Oh, look at what we got right here. Look, a higher resolution image that I just needed to zoom in a little bit more. And we can see what the ocean floor actually starts to look like. Again, we got pockets of salt domes that you can see. And then we have, again, it gets blank again, so we don't really get to see much, but there we go. And they may be covered in, the salt domes themselves may be covered, oh, wait, hold on. That might be just a conical shaped salt dome. I was going to say it looks like a volcano off the coast there. Oh my God. What if? A lone volcano off the coast of Louisiana, wouldn't that be wild? No, I would doubt that would be a volcano. That would be the top of a salt dome that's just shaped somewhat like that. Anyway, getting into this earthquake down next to Deepwater Horizon opens up a can of worms I don't even want to talk about, but there it is. There it is. What else is going on? Do you guys know about the hidden islands out here off the coast of Jamaica? I found this one mind-blowing. They've hidden that. Okay, check it out. First of all, here's Central America. Here's Jamaica. Here's Cuba. Here's Florida and the Bahamas. So between Jamaica and Central America, there's a bunch of hidden giant islands that nobody wants to talk about. Hold on, I'm not kidding. I'm not kidding. Here, hold on. Look what they show us is here, okay? This is like one little quick flyover of one little spot here. But look at our elevation here in the lower right-hand corner. It shows us our elevation. So this is 20-foot deep water out here. Out here, we got like 10 feet, 20 feet, 1 foot, 0 foot. Okay, so now we're at the surface. These are like the height of the Florida Keys. All right, now I can move my mouse along here and see that this stays 0 foot. This goes above now. We're at negative 1 foot. So, okay, then we go back up to 0, 1 foot. All right, now they say they're the banks is what they're calling these. Okay, now I'm starting to get skeptical when I get up here and I see that this whole location here, it comes up to 0 foot and then it drops off to 50 feet, 40 and 50 feet deep all the way through here. But on the edges, all the way around the edge, we're going right up to 0 foot. Let me see if I can get that. Hold on. And they're not showing it to us. So if you were to sail out here, if you were to try to sail between here and here, you'd run into a bunch of islands. Look, I'm not kidding. All islands, all the way across. From Jamaica to Central America. All islands. And you can just move your mouse across here and see the elevation come up to 0 foot and then go back down. Come up, go to 0 foot. And to call them banks, I don't know, man. I don't know, guys. It's almost like there's a whole grip of hidden stuff down here, and there's got to be people living in there. There's got to be people that would live out on these. I mean, if you're going to live at 0 foot here, let me show you an example of 0 foot. 0 foot up to 10 foot, and these are 10 foot from man-made. But here's 0 foot, here's 0 foot, here's 0 foot, here's 1 foot, goes up to 15 feet man-made. But, I mean, come on. That's the Civil War fort they built out there. So, I mean, come on. Hidden islands? I mean, come on. Look, it's the size. This is the size of Jamaica. And it's slightly submerged by 10 feet. And all the edges come up to the surface. Same with this. Well, this one's a little deeper. This one goes down to, this one's much deeper, actually. This is about 50 feet deep in water there. But then we've got some other stuff going on, again, that why wouldn't we have good flyovers of this showing us all the islands that are out here? Okay, another example. I got a few roads on it. No name. Guess Tom Hanks got stuck there and wanted to recreate. And like we got a channel that somebody has created a channel. Okay, that just Now, that one's probably documented, just doesn't have the name on it on Google. But all of these, I'm raising serious question because, again, these would be like, if you think the water levels have rose in the past 500 years, we know this for certain. Let me show you an example up here in Key West or outside of the Keys, right through here. All of this used to be above water back when the Spanish took over. Now it's 15 foot on it. So 500 years ago, that was just above sea level, like sand dunes kind of location. And so down here, you got to wonder, back 500 years ago, was this a whole nother island off the coast of Jamaica? I mean, it's not preposterous for me to ask when it comes up to 0 foot. And that it's not shown to us now because people would want to go live there. They would. People would know about this. They would just keep it secret or not talk about it. There's a shit ton of islands out here all the way across. Now, they might be populated by cartels and other things. You wouldn't want to go out on all these islands out here because look where you go over to. Nicaragua, Honduras, Honduran rebels, Costa Rican freaking paramilitary out there, probably. Drug smugglers and runners and all that. You know, I mean, come on, it goes right over to Jamaica. No wonder they keep it hush hush. I was shocked to find that, though. I was like, what? Because you'd think like people would fly over, you'd see a bunch of islands there, and it starts asking questions why they're not. Oh, it's the banks, Dutch. It's the banks. They're just 1 foot high. I'd be like, yeah, well, so are the Keys. So the Florida Keys. You could live there. It's a whole tropical paradise. The United States, if they want to try to say that this is just open water and nobody owns international water up to 200 miles off their coast, let's measure 200 miles off the coast of Jamaica. Would be right. Wait. Oh, that's kilometers. Hold on. Okay, there's 200 miles off the coast of Jamaica. And there's 200. So through here, supposedly international borders go out 200, right? Or is it 50 miles? Maybe it's 50. Either way, United States could come down here and just dump a bunch of sand and build a bunch of new Caribbean islands. Right? Just do what China's doing. Just come out and build a shit ton of new islands and everybody would move there. It would be awesome. It'd be tropical. Build it like 10 feet above sea level, no problem. You got a bunch of debris and waste you want to get rid of, the stone and brick and masonry, you just go dump it there and build an island. It's 0 feet deep. You would just start dumping sand and rock there and you'd build an island. And would a hurricane wash it away? No, not if you built it 10 or 15 feet above sea level. The way I know that for sure is they built this island in the Civil War. And this is off the coast of Key West. On the Gulf side, no less. And check it out. So can you build a man-made island and it stays for hundreds of years without any problem and even bring in a bunch of brick and build a huge fort there? Yes. So we could totally do it. You could come in and build a shit ton of new islands down here in international waters and just call it the new United States Caribbean. Yeah. Okay. Donald Trump, don't give Trump any ideas, right? The Golden Islands. That's what they. Okay. We're gonna make the Golden Islands, guys. We're gonna make them great again. Deepwater Horizon, though, I don't know about all that. That might not get me any friends. Just showing you, man. Not saying Deepwater's responsible. Just saying that the earthquake is next to it at the salt domes that was the Strategic Petroleum Oil Reserve and Ordnance Disposal Site next to Deepwater. But I'm not saying that the earthquake's a blast or anything. I'm just saying it's the same size that's going across the plate, which then says that it's the wave that caused it, the seismic wave. And the seismic wave sought out the salt domes that are drilled, and the plate's really moving. And one other thing, we can look at the current seismic, and now that we know a wave is coming across from up here and going down to here, There's only two ways for it to go, guys. One is to reflect like a check mark up to the northeast. The other would be to reflect back into itself and strike somewhere between, let's just say Colorado. Is that Colorado? Yeah, that's Colorado. Colorado to, well, between these two, what is that? Arkansas, Louisiana, Mississippi. As far as I can see, there would be two ways for this to go. One up the East Coast, one back into itself. If it goes back into itself, we'll get two earthquakes, Colorado and Mississippi. If it goes up the coast, we'll get one earthquake, and that'll be in Virginia. Or, well, East Coast. Ohio across to Virginia, across the red arrow. So if it goes up this way, it'll strike between these two. If it goes up the East Coast, it'll strike between these two quakes. If it bounces back into itself, it'll strike first or second. It'll strike between these two and between these two. Again, a wave reflecting into itself. It's just going to find the halfway points between the previous waves and come up. When it comes up, it breaks. We'll have to figure out at what point the wave comes up and precipitates an earthquake. But to do that, we're going to have to install antennas in the ground. Yeah, no, not seismometers. No, we don't need to listen for the earthquake. We actually need to put actual VLF antennas either on the ground or in the ground. And we need to listen for a radio wave, basically, an electromagnetic disturbance, but coming through the plate, it's going to be in the form of a radio wave. A VLF radio wave will be coming through the plate from Mother Nature. It'll have some kind of electric charge to it, too. It should. And that's what I think is causing the earthquakes. So it gets to a point where the wave builds and then the actual physical earth breaks, though, and I don't know what point that is. I don't even know how to measure this yet. I don't even know what term to call it. What would we measure it in columns? No idea. Teslas? Teslums? We'll have to create a new term, a combination of Teslas and columns. We'll call them senses or something. Anyway, much love, everyone. Hope you enjoyed this little micro update on this weirdness. And I'm sorry that I didn't have the screen capture turned on for the first part of this. Again, I'm a noob. I'm getting back into it. I haven't done this in a while. I got to double check on double checking when I don't have multiple screens. Excuses, whatever. You got to hear me talk for a while. It's good to be here. Much love. Thank you. Peace out. Oh, one other thing. I got a message when I was previously talking. Somebody was asking me about a post that I made. I made it yesterday, or maybe it's this morning. You guys know I delete all my X posts after a certain number of hours being up because there's no point keeping them up. But that being said, I posted a thing in response to Elon Musk, who posted something about solar and how solar is going to be replacing, there's so much solar energy that could be harnessed that it, dwarfs the amount of nuclear reactors. And, to figure out how to harness solar better would be awesome, right? And I made a post saying there's a way to get to bury solar panels in the ground, and to protect them, first of all, to keep them at the same temperature for the most part, and to protect them from the outside environment, and because they're an eyesore, and that there's a way to bury them slightly underground by like a couple inches or a couple feet, and to get the light down to them underground. And that you could also put them in your basement, I guess, or maybe even put them in the attic of your house, the solar panels, and just get the light into them, pipe the light into them, basically, the sunlight. And to be able to put several of them, just like you would put out an array on the, on the ground, for instance, if you wanted to put out a solar panel array of like 20 panels, you could take the 20 panels and bury them in boxes and put the boxes in the ground, a couple inches underneath the soil or however deep you want to put them. And we could pipe the light into the solar panel. And then I kind of left it at that because I've already explained this before on my live stream, but I didn't really show it. I mean, I showed it, but I didn't really explain it. And so somebody asked about that, and I'm going to explain it now, since you're here. So let's go ahead and turn on my display capture and make sure you can see it. There we go. Where are we? We're at the St. Louis Public Library Digital Collection here in St. Louis, Missouri. And we are looking at something from the 1904 World's Fair. It's called the Pyrheliophor, and it was invented first or discovered first by Father Himalaya, who is, now let me click this, Father Gomez, but they called him Father Himalaya because he was like 7 feet tall. There he is. And this is the Pyrheliophor. Now, it's really big. He made a really big version. And these are all mirrors. These are not lenses. This doesn't magnify the sun. It's not like a magnifying glass where a Fresnel lens where you would, magnify the sun 3 times or 5 times or something. Instead, this multiplies the sun. And think of each one of these squares as the sun itself. He measured the appropriate wavelength to capture a few inches of sunlight as if this is the sun at that height, at this ground level. So in other words, you could think of each one of these mirrors as a separate sun being reflected down. And there's 6,117 mirrors on this thing, and they all point down to this cauldron he's standing in front of right here. And inside the cauldron is a ceramic that was capable of getting up to something like 4,000 degrees or something. Well, this thing ended up going up to 7,000 degrees Fahrenheit or 4,000 degrees Celsius. And they were able to vaporize all metals. It achieved the highest temperatures known to man to date. 6,117 mirrors to reflect the sun's rays upon a single point. By this means, a heat of more than 7,000 degrees Fahrenheit was secured, and he won the top science prize. There were prizes that were given out at the World's Fair, apparently, and he won the top new scientific prize. I don't know what the name of the prize was. It says it on here. Let's see. Manuel Antonio Gomez, Portuguese priest known as Father Himalaya, suggesting a giant spider was constructed to ascertain the amount of heat. Wait, where's the thing about this? Okay, I read it in another news release about this, that he won the top prize at the fair. There's newspaper articles on this guy, and he stuck around after the fair and used this for many months afterwards at nighttime. And at nighttime, he found that this worked better than an optical telescope to look at the stars, and that they could point this at a star. And he pointed it at the star Sirius, for an example, and they were able to focus the starlight down into the cauldron and get measurable temperatures on a thermometer from the starlight from Sirius, for instance, just one star of many. He also showed it to astronomers, and they all agreed that this was way better than an optical lens telescope, like a big polished lens that we use today even. So this worked at night as a telescope. And during the day, it reached the hottest temperatures known to man. And he was trying to sell this idea to steel barons at the time as a way to smelt iron and produce steel and get impurities out during the daytime for free without having to use any combustion. Right? They were using blast furnaces. But they didn't want it. The steel magnates didn't want it because it only worked during the day, and they want their facilities to be able to produce the iron and steel 24/7. And they had coal deals too worked out with coal-fired smelters. Long story short, this got lost in history for the most part, even though it reached the hottest temperatures known to man, and it would do telescope work at night, and it's an incredible device. Now, these can be made any size. This one was for melting iron and smelting steel. And you don't have to use 6,000 mirrors. You can use less mirrors. Now, here's the thing. These can be made any size. Let me make sure you can see this. So the one he made is billboard size for this is exactly the same size as a large highway billboard. Okay. But you can make it the size of, let's say, a sheet of notebook paper. And you don't have to use all these mirrors now. We've got Mylar plastic. Sheets of Mylar, it's like paper thin, and it's just like paper, okay, Mylar. And you could do 6,117 Mylar mirrors, and they could each be the size of a disco ball mirror. I suppose you could use disco ball mirrors, too, if you really wanted to go to the next level and try and glue them all together. But you can use a sheet of Mylar and just draw a grid on it. Draw a black grid or a white grid on it, either or. And then all of a sudden, the Mylar sheet has 1,000 squares on it, and each square is reflecting the sun. The point of this is that you don't have to use 6,000, and you're not trying to melt steel. What we want is one about the size of a sheet of notebook paper, because what that's going to do is capture the sunlight at the surface and put it down into a Mylar-lined mirrored pipe, and capturing, let's just say, 20 versions of the sun, not 6,117. The reason we want to capture about 20 versions of the sun and focus them down into a mirrored pipe is because 20 versions of the sun going down a mirrored pipe, by the time it gets down to the bottom of the pipe, coming out, let's just say in your basement, it's about 20 or 30 feet away. So you're going to need 20 times the light to reach down 20 feet to your basement from your roof, because you're going to have one or two of these on the roof collecting light and piping it down to your solar panels in the basement. Now, underground is much easier because you only have to bury it a few inches. You'd put the solar panel in a mirrored box and put the mirrored box 5 to 6 inches, 2 inches under the ground, and then you only have to pipe the sun 2 inches in a little pipe that's mirrored to the underground box, and the underground box has a projector lens, a wide-angle projector lens, that takes the sun that's coming down the mirrored pipe and projects it back out at an angle down onto the solar panel that's in the box. And the distance for that needs to be about a foot, maybe 2 feet, for a wide-angle lens to project down onto something the size of a solar panel, about 3 foot by 4 foot long. Maybe the box might need to be 2 feet wide or thick to get that projection onto the solar panel. But either way, a 2-foot box underground protects the solar panel for life. And it's a mirrored box. You reflect the light down into the mirrored box. The mirrored box fills with sunlight, and it's all captured from one of these. And it doesn't have to have 6,000 mirrors. Again, you would have one of these with like 20 separate small mirrors, the size of a notebook paper, 8.5 by 11, and it's reflecting down into the ground onto at least one solar panel, maybe 2 at a time. Then you'd only have a couple of these sticking up out of the ground. Wouldn't even be a problem. And it'd be made out of plastic, so you don't have to worry about it breaking. You can even make them out of rubber and just line the rubber with a Mylar spray lining, and then they're made out of rubber like tire material, and they'll never break, and they're still reflective and reflect it down into the mirrored pipe. So then this got me thinking about cities. What if you installed one of these, not 6,000 mirrors, let's just say 1,000 mirrors, on a large building in New York City? And you know how the streets get in the wintertime, or even in they're dark and shaded. You can't get sunlight down on a lot of those city streets in between those large skyscrapers. Or if you're in an apartment that's in New York City, for instance, and you can't get sun, you're in an alleyway. Well, what they would do is they would put one of these, smaller version, up at the top of the building and reflect it down into the alley and provide full sunlight down at ground level. And that got me thinking more, which is these would be great to reflect down into the ground if you wanted to have an underground house and you wanted sunlight into the house during the daytime. And that got me thinking more. What about interior apartments at buildings that currently exist? Why couldn't you just put mirror-lined pipe in the walls, like plumbing, and on the surface at the top of the building, wherever you are, you would have one of these collecting many versions of the sun and reflecting it down far enough And with 1,000 versions of the sun reflecting down into a mirrored pipe, I mean, the heat at the reflection point at where it focuses is going to be hot, but that can be above the surface. And the rest of the light's going to go down that pipe. You get 1,000 versions of the sun going down that. You can branch it off, and everybody in the entire building, if you have a skyscraper, could have natural sunlight in their house piped in, like regular sunlight piped in via a PEX pipe, basically. And it could be smaller than a PEX pipe because we're talking light here. It could be just a little bit bigger than a fiber optic cable. Really could probably do it. But the point of this is that these would be great in the winter too, man. Oh God, this would be great in the winter for melting snow. I'm serious. Just one with like 10 mirrors on it, and it comes down to a point. You set it out, you just point it at your driveway and watch it freaking. This is Archimedes' death ray, by the way, in case you didn't know. This is the ancient Archimedes' death ray that the Greeks had that they used and shined onto things far away and melted them, burned them. That's this. Only they did it with probably copper polished mirrors instead of polished aluminum. Oh, by the way, these mirrors on here are all metal. They're not glass. But he used metal because it was apparently cheaper than for him to get a bunch of glass mirror. Mirror was not cheap then, I guess. So he used polished metal, polished aluminum, I think. It doesn't say in here, but it oh, wait. No, it doesn't. This is the picture as a glass plate negative. So when you see something like this, look at it at a greater picture. What is it? It's just 1/6. Make sure you can see this still. 1/6 of a giant parabolic dish. Like if you were to put this and connect it to another one and to another one all the way around, it would make a giant satellite dish, right? So what he's done here is he's only used 1/6 or 1/5 of a satellite dish, if you want to think of it that like that shape, a parabolic dish. He's only taken one section, and that's what it does. And you only need one section because anything more than that you won't be able to contain the heat. Once you get above 7,000 Fahrenheit, you're talking about vaporizing every form of ceramic, every form of metal, every form of everything. It'll melt rock. It'll do all that. And that's just this is multiplication, not magnification. It's a huge difference. Multiplying something versus magnifying something. Now, there is theoretically, you could put this down through, like halfway through, you could put a lens. This would be the ultimate death ray, is that you would take this light, and before it gets to the cauldron at its focus point, you would then put it through a lens and direct it somewhere. Don't do that, kids. I'm talking about make yourself blind, first of all, but secondly, wherever you would direct it would be Archimedes' death ray if you put a focusing lens and then like targeted it somewhere, right? But let's just stick to what it is. Down to a cauldron, that's good. It'll melt all things, including rock. And we don't need that, although that would be awesome to have. We just need to get light to solar panels. Right? This will work to reflect light down to your basement. All right. Like, it'll work to reflect light down the skyscraper. It will melt the water on the street if we put enough on there. Anymore, it'll catch cars on fire. So we don't want to do that much. But why not have one of these on top of a bridge that shines down like this? It catches the sun from the opposite side and shines it down. And it won't blind you because it's just maybe 100 mirrors. And it's just enough to put that light that would normally be on a dark shaded portion of a bridge and get light onto it so that you don't get ice build up on a snowy day. Simple. Small ones that you can put up that reflect light down on your driveway. Or, hey, backside of your house. Oh, this gets me because I live on a lake. On the lake here, on one side of our house, there's always wind. And the sun comes up and it goes down north, south, east, west, right? And we get that mildew or whatever you call it that builds on your siding. And we got to get the house power washed every couple of years because of it, because we're living on the lake. It's moist. So this mildew forms on the side where the sun doesn't get. Well, this would solve that. I could put it over on the angle at a 45 and reflect as much sunlight as I would need over to the side of my house. And people already do the reflection thing into gardens, but they're not doing this, right? They're using 1 or 2 or 3 or 4. There's some that use 4 or 5 for a solar reflector in a garden. I saw that. It was like a privacy fence that had a whole bunch of small mirrors. So somebody had already started to figure this out in the gardening world, that with all the smaller mirrors, you can direct different versions of the sun onto different things. And with this, it all goes down to a single point. And I'm just thinking solar panel or array of solar panels. If you had one this big and you had a gymnasium full of solar panels down below it, what if you had, think of this, a closed big box store. Oh my God, this is genius. This is genius. Ready? You guys ready to make $1 billion, Elon Musk? Here you go. You already had a bit. Somebody else needs to make this. I can't do it because I have no gumption. Just being honest. A closed big box store like Walmart, one of the ones that's closed, right? Michael's, whatever. Hobby Lobby is closed. It's a big box store. And on the roof, you install something like this, but not as many mirrors. You're not trying to melt steel. So maybe 1,000 of them. And that's on the roof of the big box. And then the whole inside of the big box store is nothing but solar panels on the floor. And one of these on the roof. And it projects down to the lens that I was talking about that we shouldn't do. Instead of the cauldron, you put it down to the spreading lens. A movie lens, if you want to think of it like that. But you're not trying to melt the lens. So you're going to capture that light just before it comes to its focal point or just after. And that's where it gets then projected down onto all the solar panels on the floor of the big box store. You can line the walls, you can line the floors, and start producing a shit ton of power out the inside of a building, and they'd always be protected in every storm and everything. They never get covered in snow or ice. Windstorm wouldn't matter. Hail doesn't matter. It's in a big box store that's closed down, that's just sitting there collecting dust. Start putting solar panels on the inside of buildings. Yes, projecting light down into the building would get the building warm inside, but heat rises, so you could just have the windows. You could put windows at the top, easy. Let it vent out from the top. And since you're collecting the light and putting it through a lens, the lens you use, why not add the UV filter glass in there so it takes out harmful UV rays to preserve the life of the solar panels while still getting the photons per inch that you would normally get? Why not? Because again, UV isn't what powers, ultraviolet rays aren't what power solar panels. That's the heat. So we'd take out a lot of the heat by removing the ultraviolet rays. The UV, by just simply having a lens that it focuses into first before it goes down into the building as it projects out. There you go. $1 billion idea. And you'd use one of these with how about one mirror for each solar panel? So, or 10 small mirrors for each solar panel. Somebody would have to do the math on that to calculate but it shouldn't take much, because if 6,117 small mirrors will melt steel, then again, 1,000 of those would probably be overkill for a solar farm inside of a building. Be great on Mars too, wouldn't it? If Mars exists. If Mars exists, you could hollow out a tunnel, put the solar panels down in the tunnel, and then use one of these at the surface to reflect it down into the underground chamber where you could go service them and you don't have to go outside. They don't get covered in dust. This would also be great to get light into underground tunnels and cities, caves, and check it out. Hear me out on this. I said this to my wife the other day when I was talking to her about this. God, you can imagine, right? She hates this. I'm like, her eyes start rolling. I'm like, oh, the Pyrheliophor, this would be. We were watching something on the pyramids, and they were trying to figure out how they got light into the pyramids. And I thought of this. I'm like, wait, Archimedes' death ray, but they would reflect light down the tunnel, and then at the first corner, they would place a sheet of metal, a sheet of polished metal, copper or whatever, and it reflects the light down the tunnel that way, and they're putting in like 100 versions of the sun at the entrance to the cave, up at the top of the cave, so you don't burn yourself. And it's not burning anybody because it's, again, dissipating as it goes down the first shaft of whatever cave you're entering or whatever ancient megalithic site. And they didn't use torches. They literally went in there during the daytime and they had reflected light that went all the way down into the interior of the structure using reflecting metal. Sheets of metal reflecting it. Easy peasy. And we know they had it because there's all these stories of the death ray, that the Archimedes death ray, that the Greeks went around and they torched all kinds of things with it. Some kind of reflecting device, they said. And people tried to imagine it as a giant magnifying glass. And all these skeptics weighed in and said, you can't have a magnification that time. Do you know what kind of and the lenses it would take? Well, it doesn't take lenses. It just takes reflecting metal. This little pieces of it, too. It doesn't take a lot. I bet they figured this first out with the chain link armor that the Greeks used to use. That square armor that they used to make. They used to make this kind of armor that kind of look like this. And I bet you a long time ago, somebody figured it out. They probably made a suit of armor that was many of these types of shapes. And the guy probably set something on fire. His name became Helios as he... Okay. Helios, old Helio, set himself on fire, but contributed to the world of science. And then it got lost in history, so I guess it didn't contribute much. All right. They did use mirrors? Was that mirrors that he used in that one? Did you look it up? I read that he used copper plates, but maybe it was a different one, or a metal, polished metal plates. But then again, he made multiples. So when you look up Father Himalaya, which is his real name is Father Gomez, you'll find out that he really made like 20 different versions of this. He even made a big lens one, a big circular lens one. And that's the one you'll find. That's the one that's like the hardest to make, the most inefficient, and the one that there's the quote unquote patent for. Yeah, right. So if you look up the Pyrheliophor, they give you the round lens version. Tell me they're not trying to misdirect people on purpose there. So he found that the small multiplication works much better than magnification. For the sun and photons, I mean. It's better to multiply photons than magnify them. And it's logical. I mean, now when you think about it, when you say it like that, it's like, oh, dude, of course, more photons is better than trying to magnify a beam of single photons, that you're multiplying those beams of photons and just skip the lens and multiply the sun instead of magnifying it. That's the way to go. And I would think that this would be great for purifying water. I mean, you could build one the size of a door for your house that would purify tanks of water for your house, just using the sun, without any solar panel, without any electricity, without any conversion or heaters or any of that crap. No heating elements. You just literally point it into a tank of water and it would boil it off into a hot steam that would then purify the water, and you would collect the steam via a distiller and drips back out. You got clear water. So I don't see, I mean, imagine that in Africa. Not nearly as big, one the size of a door frame, and that you could use to purify brackish water in India, in the slums of India. You go into the worst part of India and you get that brackish water with all the trash in it and everything, and you place it out, and then you reflect that light down in there, and you watch it all vaporize. The plastic, the metal, and the water. And then what would happen is they would rise. The metal and plastic would settle out as particles out to the side like a geyser, and the steam would continue to rise. Several of the plastics would convert into vapors and just blow away in the wind. Yeah, that'd be great. Yeah, nothing go wrong there. I guess we'll need a collector for that. We're going to need a vent hood and a collector and a petroleum cracker, and we're going to need a refinery and... Hold on, we're going to need to build an oil refinery in the middle of the slums of India in order to cash in on all the plastics and trash that are in the water that we're going to burn out. Okay. Yeah, right. I'm full of great ideas. Yeah. Nothing can go wrong with the open fumes blowing out to the wind either. Tell that to BP, right? So that to me is something that would be great for using to reflect light to solar panels underground. Back to the whole point of this, that thing, small, the size of a sheet of notebook paper, would be enough to capture enough light to power a full solar panel all day long during the day and bury the solar panel underground. If you made one just a little bit bigger, or two of them, it would be enough to pipe enough light down into your basement from your roof. 40 feet, no problem. 50 feet, let's say it's even 100 feet from the top of your rooftop to the depths of your basement. It probably isn't, but let's just say it was, that you could even project the light 100 feet, no problem, with probably a few hundred of those small little mirrors to power a solar panel. I mean, if you want to melt steel, you're going to have to do a little bit more. But all right, yeah, GoldenEye, yeah. No, that's not GoldenEye. No. That's you got the wrong Bond movie. Yeah, no. I think which one is it? Tomorrow Never Dies with the diamonds in space. Gustav Graves. Hold on, Gustav Graves. That was the villain's name. Die Another Day. Yeah, Die Another Day. He deploys diamonds in space that do this. Yes, that it's already a Bond invention. Yes, yeah, I know it'll work. It's probably based on this. But yeah, the diamonds in space from Gustav Graves and Die Another Day, and they collect the sun, focus it down to a point, and point it back down to the earth. And his thing was like millions of them. There were millions of diamonds, millions of suns. They may have overkilled on how far it could project, but it depends on how big it was, right? I know it's the size of a space station or something, so maybe it might work actually. Okay, well, hold on. We got to allow a comment here. I had to allow a comment. Yeah, India, with India, there are slums and it's really just a cultural thing. I think it's just the people have gotten used to allowing certain like debris and trash to build up in certain areas. Yeah, it's like that in a lot of countries, including the United States. As a matter of fact, I drove down to southern Missouri. We drove out through rural Missouri. We're driving down to the Elephant Rocks of southern Missouri. It's a state park. And you're driving down a highway. It's called Highway 21, and it goes south, and then you maybe get on Highway 55 for a little while, and then you go south further. But we're out on a rural highway, and we're driving by a bunch of mobile homes and trailer parks basically, and there's just trash. People, instead of because nobody can afford trash pickup out rural, right? Like you have to pay for trash pickup to come out rural. The city doesn't come get it, so you get stuck with a lot of trash when you live out in the middle of nowhere, and you don't have anywhere to put it. And so what people are doing is they're just dumping it on the side of the highway, and they'll come pick it up. The highway crew once a year comes through and picks up trash off the side of the highway. And I guess it's just they're thinking that, well, I have nowhere to put my trash. I'm living in a single wide or a double wide, and I'm packed in with a bunch of neighbors. I can't just bury it in my backyard. Can't burn it outside. It's toxic, and we got some fumes and some other stuff that we don't want to do outside of the trailer. So you go dump it off the side of the road. And that's what they're doing here. And that's civilized Americans doing it, right? So I'm guessing the same thing exists over in India. Only there's a billion people in India, and they're closely packed together. You know what would be great? One of these devices about the size of a cardboard box, standard Amazon box, and some a little bit bigger than a sheet of notebook paper, but just something that's and that you could put your plastics in, and the light would reflect down into it and melt it down into a flat sheet only. You're not trying to vaporize it. It would just cause it to melt and go into a flat sheet. And you would throw more plastic in there, and the next day when the sun shines down, it melts that too into a new sheet. And it starts doing layers of plastic. And you would just toss your stuff in, and it would slowly melt it. Okay, it wouldn't release fumes. I'm talking about just making the plastic soft. And then it has a compressor like a trash compactor, and it presses it down into a layer that's compressed. And you could take all your plastics and throw them in there, and over a period of time, you'd build up a big block of plastic. that was ready to use, and you could take that block of plastic and then drop it off, and it would be usable, and they could use it for stuff to melt it down further or easily disposed of that way instead of taking up all that space. Maybe even use it, it could press it into blocks. Why couldn't you use that plastic pressed into blocks for building material to build new houses? Like they would use cinder block or something, I mean, why not, or at least retaining walls and get the microplastics and everything. It'd be great. I got a great idea. Let's eat the stuff. Let's grind it up into a fine powder. Let's figure out a way to make microplastics eatable. You like that? I got it. AI, we make Tesla robots. Guys, hear me out. Hear me out. Tesla robots that are powered on recycled plastic. Doc Brown, think of Doc Brown in Back to the Future putting a banana peel in the back of the DeLorean to go fly into the future.